Okay, folks, we're going to talk now about finding the axis of symmetry using the x-intercepts and what the relationship is between those. We haven't talked much about x-intercepts yet. I don't particularly like this topic here. I think it should wait until after we deal with the next unit, but we'll squeeze it in there. I'm sure most teachers are probably going to wait until later, but just to stick with the order of the course, we will put it in there the way it's laid out. So we're going to talk about finding the axis of symmetry here. By looking at a graph. We're going to talk about finding the axis of symmetry from a table of values, and then we're going to look at finding the axis of symmetry from an equation using a symmetry strategy. This part is kind of an optional thing, so many of you may not be doing this, but I'm going to put it in there just in case you are. If you're not, your teacher says you don't have to do it, please feel free to skip away. Okay. So from a graph, we all know that the axis of symmetry is a line that goes directly down through the middle of the graph, okay? But we're going to be a little more specific about that now, or we're going to relate that a little bit, I should say, to some of the other features of the graph. So there's our axis of symmetry, and we can see it's going to be at x equals -1. But let's say we didn't know, or we didn't have the graph, and we didn't know it was at x equals -1. But what we did know is what our x-intercepts are. And in this case, we can see they're at -3 and +1. Well, one other strategy that we could use to figure out the axis of symmetry with that information is to realize the axis of symmetry, since it is a symmetric thing, would have to be exactly halfway between your x-intercepts. So you could find your axis of symmetry by saying x would have to be equal to the average of those two things, and that would be halfway in between them. So that would be like -2/2 here, which would give us x equals -1, which is what we expected. So we can try that again over here. We know it's going to have to be halfway between -2 and +4. So our axis of symmetry will be at x equals, let's see, halfway would be the average. So -2 plus 4 divided by 2, which should be 2/2 or +1. And if we look at the graph a second time, we can see exactly that that's where the axis of symmetry is. So the idea is that the axis of symmetry should be halfway between your x-intercepts, or the average of the two. Now, from a table of values, it's the same idea, we just have to remember how we identify x-intercepts. So if we take a look back quickly at the graph, remember that at an x-intercept, you're going to have an x-coordinate, but you're right on the x-axis, so you're neither up nor down, Grand Old Duke of York, which means that your y-coordinate is going to be 0. So in a table of values, we're just looking at where the y-coordinate is 0, and those will be our x-intercepts. And they're usually pretty easy to spot if they're given in the table. So in this case, we can see that our x-intercepts for the first one show up at x equals -3 and -1. So our axis of symmetry then would have to be the average of those two, which is going to be x equals -3, -1 plus -3. Let's do them in that order. All divided by 2. So that's going to be -4/2, which is -2. And if you look exactly halfway in between those in the table, we could have picked that out anyway. Well, that's not always the case. What happens, like in the second example, if it's going to be somewhere where we don't have a point in between? It's still pretty easy to guess it's going to be halfway between 7 and 11, or between 3 and 15, etc. But let's go through the procedure here. We're going to say the axis of symmetry will be at x equals, our two x-intercepts were 3 and 15 divided by 2, which is going to give us a value of 9, which if we double check is in fact halfway between 7 and 11. Okay, so the relationship between axis of symmetry and a graph, axis of symmetry and a table. Now this is the part that I'm not too keen on, because it does jump the gun a little bit in terms of our algebra. But we can, if you want to skip it now and revisit it later, that's fine. So remember at the axis of symmetry that y has to equal 0. So if y is going to be equal to 0, we use what we call a common factor strategy to find our x-intercepts for the first two examples, and then we're going to use something called a partial factoring strategy in the next two examples. So if we look at this polynomial here, and this might not make a whole lot of sense yet, but it will become clearer later in the course. So we'll take out a -3x as a common factor, and then we're going to have an x minus 3 left over. So that's some grade 10 factoring for you. And then we got to use this magic thing called the zero product property, where if I have two things like these that are multiplied together, and the answer is 0, the only way for that to happen is if at least one of those two things is 0. So we'd say that -3x could be 0, or x minus 3 could be 0. And if that's the case, then x would have to be 0 here, or x would have to be 3 there. And those are the x-intercepts. So then that means that our axis of symmetry, we got to split the difference. So it's going to be at x equals 0 plus 3 over 2, which is 1.5. Okay? That's a bit tricky. Let's try another one. We're going to take 0 equals, in this case, 5x squared minus 8x. Take out that common factor of x. We've got 5x minus 8. And that means that x would have to be 0, or 5x minus 8 would have to be equal to 0, meaning that x here would have to be, 5x, sorry, would have to be equal to 8, and telling us that x would have to equal 8 over 5. All right? For these next two, we just kind of cheat a little bit. We don't go for the x-intercepts. We just find two other points that are kind of up there. So we use what's called a partial factoring strategy. So I take my equation, and I factor out a 2x, leaving me with an x minus 4, and I still have a plus 7. So I can't take a 2x out of a 7, so I just do that much. And then I know this one would give me a root at 0, and this one would give me a root at 4, so I know my axis of symmetry has to be halfway in between those two. So I'm going to say my axis of symmetry here would be at 2. And I know that's weird, but we're just doing it. It might make more sense for you later on. So in this one, we're going to take out a common factor of negative 5x, and that's going to leave us with x minus 4. And we still have a negative 11 tagging along. This one's going to be x equals 0. This one is going to be x equals 4 if we were to solve those. And again, halfway in between those two magic numbers is going to be x equals 2 for your axis of symmetry. Weird stuff, but the moral of the story is that we can find the axis of symmetry knowing it's halfway in between the x-intercepts. And then we just use the properties of symmetry. So from a graph, we find the average of the x-intercepts, and the same thing from the table of values. From an equation, we find the x-intercepts from the equation and then find their average. Or when finding that is not easy, we use that partial factoring strategy. I hope that's helpful for some of you, or at least those of you who are actually going to do it that way. Okay? Good luck.